So now we're going to look at how we can classify data sets based on the context in which we look at them. So thinking about those books from before, we could say that the collection of every single book ever written, despite being something that's functionally infinitely long, is the population that we would be studying there. The population is the set of all possibilities, all outcomes, all things from which we are trying to draw some information. It's the set of everything. And when we're taking a measurement on a population, we call that a parameter. And in a lot of ways, we view a parameter as something that must be true in a sense. It's sort of a universal value. And when we get further on in the semester, we'll see about how we can talk about how universal those values really are and if they're actually as good as they're cracked up to be. But as good as a parameter can be, truth be told, it's usually a bit difficult to get a meaningful one. Like with the books, you can't necessarily go through every single one ever written to try and figure something out. There's just too many. So when we're talking about these sort of things, we usually restrict our scope a little bit, and we talk about things called samples instead. A sample is just a subset of the population that we focus on. Usually we like our sample to be representative in a sense. That is, that when we take our sample, it meaningfully shows information about the population. It tells us something meaningful. It's not just noise because we happen to pick a weird group within the larger population. And when we look at samples, when we're taking measurements on samples, that's when we are drawing statistics. So in that way, we can think of statistics not just as the science of collecting and interpreting data, but we can think of statistics as the study of samples. And that's what we're going to be doing a lot of here, is looking at things that happen to samples and later seeing how those things that happen to samples compare to what we expect from populations. But it's important to bear in mind that when we're talking about these things just in terms of their definition in this way, there's a lot of wiggle room with regards to how we make the distinction between a parameter and a statistic, or between a population and a sample. Because really, the only difference between a population and a sample is whether or not we place what we're talking about in a broader context. So if I want to figure something out about the entire United States, obviously finding all about 400 million people at this point wouldn't really be meaningful, or it would be very meaningful, but it would be unreasonably difficult to do, excuse me. So you take a subset of them. Say you just look at the people in Florida. And there we would say the population is the population of the US, and the sample is the population of Florida. But let's say I don't care about everyone in the US. Let's say I really only want to know about the people in Florida. Even then, there's quite a few people in our little state. So you may not want to have to deal with all of them. You may just say, well, let's focus on Fort Myers. And then your sample becomes Fort Myers and your population becomes Florida. But if you wanted to, you could restrict again and say that all you care about is the population of this room that I'm standing in, which, as far as I can tell, is just me. So when it comes to the distinction between a population and a sample, it can be easy to misplace which is which. The main thing you should be watching for is whether or not what you're trying to talk about, the group that you're trying to describe, is stated as being part of something bigger. That's where you get the idea of being a sample, as being something contained within a larger group.